Earlier this year, Professor Claire Gilbert of the London School of Tropical Medicine told us about the third epidemic of retinopathy of prematurity, which is occurring in low resource settings. She explained that there are a number of causes, but an important one is high and fluctuating oxygen levels, with hyperoxia and hypoxia. Too much oxygen is toxic. It damages blood vessels. However, higher oxygen levels also make it more likely that the preterm neonate will survive. She told us that in the first hour we should avoid resuscitating with pure oxygen, we should delay cord clamping, and we should prevent hypothermia. High quality neonatal care is required, and there is a need for good oxygen management, but that requires expensive equipment which is not often available in low resource settings. She explained that there are a number of causes, but an important one is high and fluctuating oxygen levels. The same is possible for neonates, and the cost is under £100 for each piece of equipment. Here is a prototype of the machine, built on the kitchen table, or in this case, the dining table. The level of oxygen can be manually set here. The oxygen concentration is controlled by a computer-driven valve to maintain the concentration at the required level. It will maintain the oxygen within 2%. The computer alters the valve to provide a higher or lower oxygen concentration according to the selected value. The level of oxygen can be selected by the clinician. The level of oxygen required and provided are documented on an SD card. This is at regular intervals, which can be selected as often as once every second or longer intervals if required, and then can be reviewed at a later date. The data can be read from the SD card onto the computer. The machine data can be documented with an ID specifying which file, and this shows the data that we were collecting during the demonstration. There is a real-time clock present which shows that this is the 3rd of September at finishing at 10:46, and here is the data collected every second. It shows the required oxygen concentration and the oxygen concentration provided according to the oxygen sensor. The data is then fed into an Excel spreadsheet, and you can see here that the oxygen selection, which is the blue line, and the orange line, which is the oxygen level provided, remains within a good range. The equipment can be regularly calibrated by the user using air and 100% oxygen. This equipment allows good oxygen control in a low resource setting. Here we can see a neonate receiving nasal CPAP with nasal bubble CPAP. All this equipment is readily available over the internet. The level of control is better than in many Western high-resource units. The equipment can be put together by any technician with an understanding of computers.